Welcome to this course on computer programming. In this session, we will study how to access and process records directly in a binary file. You will remember that last time we wrote a program to create a binary file which contained fixed length records. Each record contained data for one student. There were 4 fields in each record: roll number, name, batch and marks. What we wish to do in this session is to see which C++ functions are to be used for directly accessing and updating records for students. First, we will look at some basic aspects of accessing records in a binary file. Binary file, or like any other file, is a sequence of bytes and there is a file pointer FP associated with the file name. Now please note that an internal position indicator is maintained by C++ for each file. Any reading or writing actually occurs only at this byte position, and whenever a reading or writing occurs, then this indicator is automatically advanced by the number of bytes read or written. So this is a feature of C++ file processing. Now this position indicator is normally hidden from us, but for binary files it is possible to A, find out what is this position indicator, and B, it is also possible to set this position indicator at a specified byte. In fact, these two features permit us direct access to records in a binary file. For example, to find out the current position of the position indicator, we can use the function ftell. It is like tell me where the position is. So if I say ftell fp and assign it to a long int pos, then pos will now have the value of the position indicator, which currently the position indicator is positioned. If I want to read or write at this position is okay, but suppose I want to read or write at some other byte position p, then I can use a function fseek. It is like seeking a position in the file. Please note the parameters. Fp is the file name, p is the byte number to which we are seeking. Seek underscore set is merely a parameter which indicates that the number of bytes or the displacement is to be counted from the beginning. In effect, p will be the number of bytes of the file at which point I would position the indicator. There are 2 or 3 other choices, but this is the most important and most frequently used choice. So to recapitulate, A, we can find out the current position of the position indicator by ftell, and B, we can set the current position indicator at any place that we desire by using fseek. Once we do that, the 2 functions fread and fwrite can be used to read or write data. Please note, both will operate at the current position indicator only. Fread will read as many bytes as are specified by the record size and number of records from the file fp into the structure variable s whose pointer is passed. Exactly in the same way, fwrite will write the contents of a structure variable whose pointer is passed to an output file fp. What it will do is, from this point it will write as many records as we say here, and it will write exactly the rec underscore size of number of bytes. It is possible that we may wish to reset the internal pointer to beginning of the file. There is a special function called rewind. It is like rewinding a tape to bring it to the beginning position of the file. Equipped with this, we can now write a program to process student.db. This is merely a program for illustration. So I have used this opportunity to illustrate 2 features. One, how can I search for a particular student whose roll number is given sequentially. Please note that although the file is a binary file and permits direct access, I can always process the records one after another sequentially. So we will do that, and we will also see how we can directly access a desired record. So let us see what we do in this program. We define the struct student info as before. We define a student info type variable s. These are the internal variables that we use. Rec size is the size of struct info, and we know that this is the record size which would be read or which would be written. We have a single file to process, the same file from which we will read data and the same file to which we will write updated data records or additional data records. So, we use a spatial parameter in the if open statement. The name of the file is student.db of course, but we open as RB plus. It means ordinarily it is open for reading, but I can also write to it, I can also append to it. This is a binary file represented by B. As usual, if the file pointer returned is null, I print an error message and get out. Otherwise, I start with, let us say, a variable found equal to 0 and count equal to 0. Notice what do I do? I first rewind FP. Now I am searching sequentially for marks of a roll number 10105. So what do I do? I set R equal to 10105, set found to 0, and exactly like I would have searched in a sequential text file, I start looking at records one after another in the binary file. I also note the current file position by using ftell so that I can print it when I find the desired number. The problem is to find marks for the roll number 10105. So let us see what we do. I set up a DoWhile loop by the way this time. So what do I do in the DoWhile loop? I first read one record in the structure pointer S. Once I got S, I got s.roll, s.marks, s.batch, s.name, everything. So I simply check if s.roll is equal to the given R. If it is, then I have found the student, I will print the record. So all this is print this record. It is found at position divided by rec underscore size plus 1. So this is the record number. I output the message that the record is found at this record number, and I print the name and marks of that student, and I have finished. So I need to get out of this DoWhile loop. So in case I find a record where the roll number matches, I simply print that information out. Otherwise, what do I do if that is not so? Else, I again recalculate the pos, which will be the current position, which will be the next position after that record, and I read the next record and go back for the while loop. What is the condition of the while loop? While not end of file of FP. Notice that I could have used the while loop, I am using DoWhile loop here, but both serve exactly the same purpose. If at the end the roll number was not there in the file at all, then I will know it because found will still remain 0, and if found is 0, I will say roll number not found in the database. Next, I try to demonstrate how direct access to records can be done. So what I am trying to do is read and display the 6th record in the file. This is an arbitrary number, 6th record. So how do I go directly to the 6th record? I set rec num as 6, and then I calculate the position of this record, which is equal to rec num minus 1 into rec size. So this is the place where the 6th record will begin. Now I use the fseek statement to set the internal file position pointer. Fseek fp pos seek set. So this will set the internal pointer to the beginning of the 6th record, and when I issue a fread command, it will read actually the 6th record. One record of rec size will be read into the pointer into the structure variable S, whose pointer is passed. I just print out that, just for verification I print the roll number, name, batch and marks, and I say record number is rec num. This will verify whether I have correctly read the stipulated record or not. Here is another example of updating the record of a particular student. For example, I wish to update Neelmani Raut's marks to 93.5. You will recall his marks were 91.5. Now his roll number is 10108. We access 8th record starting at 7 into rec size. How do we understand this? Well, roll number is 10108. We presume that all roll numbers were serial 10101, 10102, 10103, etc., etc. In fact, towards the end the file has some missing roll numbers, but if we assume that database has been created for all roll numbers, then it is easily possible to figure out the record for a given roll number. What do? We say record number is simply R minus 10101. In short, this is nothing but a mapping between the roll number and a record number. Once such a mapping is available, for any roll number we can calculate the record number, calculate the position of the starting byte of that record number by simply saying pos equal to rec num minus 1 into rec size. Now we do an fseek which will directly take the internal file pointer to the desired position pos, and once we go there we simply read a record. This will be the desired record. In fact, we print out the record of Nilmani so and so, and this is the detailed information. But this is about reading. We want to change his marks from 91.5 to 93.5. So what we do? We have the values of Nilmani Raut's record in structure variable s. We simply set s dot marks equal to 93.5. All other elements remain the same value. Now I wish to rewrite this record in the same position, but please note that the actual act of reading the Nilmani Raut's record has advanced the internal position indicator. So we need to bring it back. We simply fseek again to the same pos which was issued when we wanted to read this record. We know that at this point Nilmani Raut's record begins. So file pointer is actually brought back to the beginning of this record. Now when I write, actually the old record is rewritten with the new values in the structure variable s. Note that the s dot marks is now 93.5. So it is this value which will be written. Are we sure that a new value has been written? Well, it is simple to verify whether correct data is written or not. I again do an fseek. Please note, fwrite will also advance the internal file pointer by one record length. So we bring it back by using fseek, again read this record. So we first read a record, updated it, and again read it to verify. Now when I output the updated record, I will know whether the updation has happened correctly or not. At the end, of course, I close this file and return with a 0. Let us look at the execution results just to understand how the program has progressed. It prints size of each record is 44, then it is searching sequentially for marks of roll number 10105. Through the iteration that we had set up, it found roll number 10105 at record number 4, and the name and marks are Nandan 67.00. This number is written as 4 because the actual internal number starts with 0, otherwise actually a fifth record. Next, we were demonstrating direct access to records, so we want to read and display sixth record. The record starting at byte position 220. Please note this 220 is 6 minus 1 into 44, which was the record length. So this is the starting byte for the record number 6, and this is the record 10106 Avinash this. Next, most important, we want to read a record, update its values and rewrite it. So read and update Nilmani Raut's marks. Nilmani Raut's roll number is 10108. So record for Nilmani is 10108, Nilmani 111 91.50. Now updated record in database file is this. So we confirm that earlier value was 91.5, new value is 93.5. In summary, we have seen that records in binary file can be written and accessed and processed directly. We typically search on a key attribute such as roll number. What is important is we need to know a mapping between the record number and the desired record. Such a mapping is a study of a separate field called databases or file management, but we can understand the basics very clearly. I will request you once again to refer to C++ tutorials. In the reference section, all the functions listed under C stdio. In the handouts that will be released this week, tomorrow onwards, you will provide a summary of all the functions and the file processing along with the listing of all the programs that we have discussed. Thank you.